I hope you did this problem already and tried it yourself. It is the same function that we were dealing with a few slides back. So that will make all of the work a little bit quicker. I'm just going to reference my work that we did earlier when trying to find the points of inflection. We start by getting down to the second derivative of the function. We say points of inflection can only happen when the second derivative is 0 or does not exist. We can only get 0 here as an option. And that leads to two values where we could have a point of inflection, a value of -2 and a value of 8. If I wanted to find the actual points, I'd plug in -2 and 8 into my function. Let's go ahead and do that. When I plugged in the value of -2, -2 comma f of -2, I ended up with -2, and the y value was -32 and 2/3. When I plugged in the value of 8 into my function, I ended up with a y value of -652 and 2/3. So those are the 2 points of inflection. I do want to mention before I move on that remember the definition of point of inflection is where we change from concave up to concave down. Just because the second derivative is 0 doesn't automatically mean the point is a point of inflection. You could have concave up, then change to another concave up. But we know that these two are points of inflection because we've already calculated that at -2, it changes from concave up to concave down. And at 8, it changes from concave down to concave up. So we already know those are points of inflection. Otherwise, you probably should check that we go from concave up to concave down or the other direction.